The goal of this video is to give an introduction to Apache Flink, as well as answer some basic questions, things like what is Apache Flink, um, what are some advantages of using Apache Flink, and how does it compare to its competitors, as well as we'll have a quick demo. But basically just want to give a good introduction so that you know what Apache Flink is and how it might fit into your project and what benefits it might bring to whatever it is that you're working on. So what we're going to do is we're going to start with a basic introduction to Flink. We'll cover some of its interesting features that might set it aside from some competitors. Some features are obviously going to be shared with other streaming platforms like Spark, but we will talk about those anyways. We'll then have a demo, which is admittedly not a very interesting demo, but nevertheless, I think it's helpful to kind of see how easy it is to get set up and running with Apache Flink, streaming from a Kafka service running locally on this machine that I'm recording the presentation from. And then we will see some code examples. This talk does go on the assumption that you have a basic understanding of what Kafka is, for example, what a Kafka topic is, how it works, just the basics really, as well as a basic understanding of what streaming is and what streams are and how they work. As I said, we will show some code examples of what streaming code might look like, particularly with Apache Flink connecting to a Kafka topic, but nevertheless there will be some content which is discussed that might be hard to follow if you don't have that basic understanding. So with that out of the way, let's jump right into it. The basics of Flink first. It is an open source distributed streaming platform. Some of its competitors are Apache Spark, the Kafka Streams API as well, something like Apache Storm. But what sets it aside from some of those, and as shown here in this diagram, is the fact that it is deployed as a standalone cluster. So here in the middle, this squirrel icon represents Flink. This is the Flink logo. It will then consume from some sources, which can be Kafka or a Twitter feed or a number of other examples, which we'll talk about later. So it consumes from those sources, and then we'll provide that data in different formats that can be consumed by your application. So on the right hand side you'll see we have streams in the middle, which is the probably most common, and this is the primary focus of the topic of this talk that we're going to be going over. Applications at the bottom is referring to the lower level callback API that Flink can also expose. So something like you might see in more traditional messaging systems like Apache ActiveMQ, where you have this on message callback, which gives you more low-level access at the individual messages that are coming into your broker, but doesn't give you the flexibility or the abstraction that streams provide to, say, filter or map and so on. But sometimes, nevertheless, those things might be useful, so that's what's meant in this applications box at the bottom on the right-hand side. Direct access to those messages. And then you have streams, and then at the top, in the higher level of abstraction, Flink also provides a SQL table, SQL query API where you can actually write SQL statements to run over dynamic tables that are constantly changing, and then your application will consume that data in a continuous manner. Flink also supports a number of different languages, so Java and Scala, and Python is currently in progress. The core components of Flink are event streams, which I think is obvious, state as well. Flink provides a managed state that you can optionally use in your application so that you can be guaranteed fault tolerance. So you don't have to worry about that. You just get the managed state from Flink, set your state variables onto that managed state, and then Flink will take care of all the fault tolerance for you. Flink is also event time. This is one of the core components of Flink. So Flink provides 3 different ways of handling time in the events that your application will be consuming. So event time means the time in which the event was generated. So you might think about a mobile device which is generating, say, GPS events to some remote application somewhere that will be consumed and processed, and then used in some way to, I don't know, generate locations on a map or something along those lines to track where you're moving through a world or a territory. So since those events would be coming from a mobile device, the device may be losing connectivity. You might have connection 1 minute and then lose connection the next, and that'll come back a few minutes later, and the whole time you're generating events and you're storing them locally when you don't have that connection, and then uploading them all once you do have connections. So the time in which Flink actually sees these events might be very different from the time in which they're generated. And this is what's meant by event time. And so Flink allows you to process events in event time. And it can achieve this using something called windows, which we will talk about. But for now, we'll just leave it at that. Flink also has the concept of ingestion time, which is the time in which Flink ingests the events, and as well as processing time. And that's just processing time is, like the developer is saying, give me the events just in the order that they come. Doesn't matter. I just give them to me in any order as they come, and I'll take them no matter no matter what delays they may have or whatnot. So there's those 3 different types of time: event time, ingestion time, and processing time. And this is all configurable in the streaming job that you're going to be writing with Flink. And finally, the last kind of core component or core concept of Flink is something called snapshots. So in order to achieve this managed state and fault tolerance, Flink uses snapshots. So when you're writing your streaming job, you are essentially storing state in memory and accessing everything in memory time. And as the application is running, or as the streaming job is running, Flink is taking snapshots of this memory and storing it to disk, just very, very quickly, faster than once a second. But storing snapshots very quickly. And then if a node happens to go down, when that node comes back up, it can restore the state of memory from that snapshot and then replay the events that occurred from the moment of that snapshot onwards, so that everything is kept in sync, and that no data is lost, and your application remains in a good state. These snapshots also provide some additional functionality or some additional tricks that you can play with Flink. So for example, say your streaming job is processing some events, like say you're ingesting a series of updates to some video on demand assets that are going to be shown on the TV at some point. And for some reason, something happens and one of those updates causes a problem in your application. Well, what you can do is generate a new version of your streaming job, which includes additional logging, additional debug information, maybe even has some changes to some classes, whatnot. Deploy that job into Flink alongside your original job, load a snapshot into this new job that has additional debugging information, and the snapshot will have been taken before the problematic event. Then that way you can replay the events up to the point in which your application started having problems and see, with this additional logging and debugging information that you've added, exactly how your application behaves and what might have been the problem. So it can be used for debugging or even to test a fix on an event that happened in live production, rather than trying to set up some test which reproduces the same behavior but might not have been exactly what happened. So there's some nice tricks that you can play with those snapshots. And that's why these snapshots also provide you some fault tolerance, because you can reload the state of memory at any time. So I think that's it for the basics of Flink. Now, as far as fault tolerance goes, and exactly once delivery and guaranteed order of messages, this tweet I felt was very appropriate and makes it obvious that not too long ago people thought that exactly once delivery and guaranteed order of messages was an impossible problem to solve. People have made bold claims that exactly once delivery is just simply not possible in a distributed system. Well, time has gone by, technology has advanced, people have gotten smarter, and now that problem has been solved. Flink does provide guaranteed exactly once delivery of messages and guaranteed order of messages. Now, how can this happen? How can you have a message delivered more than once, or a message not delivered at all? So imagine that you have a producer generating messages to a Kafka broker, which is then connected to Flink, and Flink is generating streams for your streaming job. So the producer, which is generating messages for Kafka, and then of course Flink. So say one of the Flink nodes goes down, say the producer does not receive an acknowledgement that the message was consumed. Now, the producer, when that broker comes back up, the producer may say, okay, I didn't receive acknowledgement that this message was consumed, so I'm going to try to send it again. So there's some retry mechanism enabled on the producer. Now, what that means is that if the Flink node did receive the message but simply went down before it could send the acknowledgement, you're going to end up with duplicate messages because the producer will resend the message and then it'll get reprocessed a second time. Now, on the other hand, the producer may say, I never want to get into a situation where I could end up with duplicate messages, so as long as I'm able to send the message, then I will not retry. If the Flink node goes down and say doesn't receive the message, when it comes back up, the producer will not retry to send that message. The data is lost. So in that case, you will have 0 deliveries of the message. So what Flink guarantees is that we will always have exactly once delivery. You will see that message exactly once, no more, no less. Now, the guaranteed order of messaging is where windows come in. And this is something that is probably familiar to anybody that has already done streaming with Spark, or I believe even the Kafka Streams API gives you this. I'm not certain, but with Flink, you can generate a window using their API, which says, in this window, I want to make sure that the messages always arrive in order. Now, what do I mean? So, in your streaming job, you may set a window to, say, 1 minute. So let's say something happens on the producer side, like your mobile phone loses connection, and somehow an event which happens, say at 11:30 in the afternoon, arrives before an event which was originally generated at 11. Now, because your I don't recall if I said the window, let's say the window is an hour then. So when this 11:30 event arrives, it will sit in this window for at most 1 hour until it knows that the event which happened at 11 has arrived. So the Flink knows the sequence of messages that are meant to come into the system, and it can say, okay, this message arrived at 11:30, but the message at 11 should come first, so I will feed that to the application first. So the window gives you this guaranteed order of messaging within a certain time span. And that's, of course, configurable and not necessary, but often it is a very useful feature. Now, the downside of using these windows, and obviously you don't normally set a window to an hour, or I imagine that's probably not what most people would end up doing. You might say, I don't know, a few seconds or a few minutes, probably at most. But in any case, the downside of using windows is that it does introduce an inherent latency to the time in which your streaming job will finally process the message. But oftentimes that's an acceptable trade-off, given that you can guarantee then the order of messages. And so this is how Flink achieves that order of messages, is using these windows, and they're highly configurable. So you can just use a simple rolling window, which you just set the time, and it just moves along as time advances. There's also the concept of sliding windows, which move around in different ways, and various other options that you have right there in the API that are quite easy to use. And so that's basically all that I wanted to say about that. So as for different types of connectors that Flink offers, so here we have sort of a gradient where you have sinks on the right side and sources on the left, separated by these little gray dashed lines. So sinks are basically places where you can output the results of a stream. So in the middle, we have things that can be both sinks and sources. On the left, things that can be sources only. In other words, they can only be the source of one of your Flink streams. And then obviously on the right, we have things that can only be sinks. So I do want to mention that at the moment, let's see, ActiveMQ, Flume, Redis, Akka, and Netty are connectors which are supported through a subproject called Apache Bahir. Not that that matters. I guess what it means is that there is a dedicated subproject for Flink which is working on different connectors for systems that might want to be either sinks or sources to Apache Flink. And what that means is it reduces the risk for you to start using Flink because there is active development to add additional connectors so that any technology you might want to use, you're not limited because of lack of support in Flink. There's many being added quite frequently, and obviously we've got the core things here. So obviously Kafka is the number one here in the middle, which can act as both sink and a source. ActiveMQ and RabbitMQ if you're using a slightly older messaging system, and even Hadoop file system on the right can be one of your sinks. That information will hopefully be useful. And I actually probably won't be too important for anybody that's interested in using Flink in production, but Flink does, of course, come out of the box with some predefined data sinks for support to write to files and standard out and standard error into sockets. But I think more often than not, you're going to end up using something like Kafka, and they're very easy to set up. You just add the dependency in your Maven POM configuration, and then you're ready to get going. And actually, we will see an example of one of the the Kafka connectors after the demo. So speaking of the demo, I think we're ready for that. As I said, there isn't much to the demo, but it does show how easy it is to get set up, because I'm just running this locally here on my machine. There's not much to it, not many lines of code. We will look at some of it, but it was quite easy to get set up and running. And this is a Kafka to Flink streaming job. And one thing I did want to mention, and you'll see it in the demo, is that the streaming jobs are compiled. You can build them using Maven. There is a POM configuration which Apache Flink provides to generate a jar file, and then you run a single deployment command to publish that job into your Flink cluster. And then once it's running in Flink, then everything's ready to go and you can start using it. So let's take a look at that and see how it goes. So the first thing I'm going to do is start up Kafka. Okay, so I'm just running this as a Docker container. Next, I will start up a local instance of Flink. And I will bring that up as well. Okay, so here's my Flink dashboard. As you can see, I have no running jobs. I then have my Flink job. So I'm going to deploy that Flink job into the Flink instance that's running here on my laptop. And what that looks like is just this here. So I just do a Flink run, give it the main class that that I want to use for the Flink job, and then the name of the jar file where that job has been compiled to. I'm not going to show, using the Maven commands to generate the jar file. I mean, it is what you, oh, well, you can see here I've commented it out. It's just a Maven clean package, and that's it. You don't have to actually set that up yourself. If you, there's a framework given to you by Flink just to get up and running with that quite quickly, and then you're free to customize it as you wish. But in any case, I've just put this stuff here in a little script file for me to run, so I can deploy that. And then what I've done is, in order to make it easy to publish test messages into Kafka, I've set up a simple Spring Boot HTTP listener. So it's just a little mini HTTP application listening for messages on a given endpoint. And when it receives a message, it immediately just takes that message and then posts it into, or publishes it into, the Kafka topic, and then of course Flink can consume that. So because it's not, for the purposes of the demo, I wanted to make it easy to get a message into Kafka, and I figured the easiest way to do that is just to expose this HTTP endpoint where I can just use a URL parameter and get the message into Kafka that way. So let me get that up and running. So that's just here in this little Spring Boot application. Here's my HTTP listener, and it's just sitting here on this Kafka path. Then the producer will send that payload to Kafka. The Kafka producer will send that payload to Kafka. You see that here. Okay, so let me start that up. And I mean, super easy to get this set up. You can see it's just a few lines of code using Spring Boot. Okay, so that's up and running, good to go. My job is still running, as you can see here. And now, if I go and curl, let's see, yeah. So here I've curled that HTTP listener that I set up, sent hello world to that listener. It should then take that message, post it to Kafka, or publish it on the Kafka topic, which I've just hard coded into the application, and then Flink will consume that, stream it to the streaming job which I set up, and then basically it'll just output it to a log. But what we can also see is if we add a metric onto the streaming job in Flink. Let's see. So you have, out of the box, you get this dashboard where you can add metrics to your jobs in order to see statistical information about the job. So I'm going to add a num records out to my source and make this a little bit bigger. And yeah, you can see this is already at 1. So now if I, give me a second, rearrange these a bit to make them easier to see, make things a bit bigger. Okay, so you can see this is already at 1. If I curl a few more messages, hello world 2, hello world 3, and now my metric goes up. This tells me that, okay, everything's working fine. The streaming job is receiving messages from Flink, and these records are being processed through the stream. There is an output file where all the output is going, but I don't think we need to see that. It's really just these strings showing up in that file. But the point is, very easy to get set up and running. You know, no special tricks to get that going. Okay, so let's take a look then at some of the code that is required to write the Flink job. So if I come back here to my slides, we'll take a look just at the basic structure and see what's all involved and what it does, what it means. So the first thing here is this setting up your environment. So the first thing you do in your streaming job is you get the execution environment. On this environment, you can set the parallelism to specify, how many threads are going to be processing your job. You can set the time characteristics, such as event time or ingestion time or processing time. You can add sources to this environment. So sources are like, consumed from this Kafka topic, consumed from, some Twitter feed, and so on. Once you set up your source, you get something like this. So you have your environment here. See? So we have this env environment. We add a source to it. Now, this taxi ride source is just a little exercise that I was working on, just a custom written source which processes a data file. But obviously, you could imagine that a different source, and we will see an example, but a different source might be a Kafka topic source, where it's consuming from a topic, and then the return value from this add source method is your stream. And then you can take this stream and start applying functional operations on that, things like filter, map, and so on. Okay, so next we have, here's one of our functional operations. And anybody that's done any work with Java 8 will be familiar with this already. It's all same or similar semantics. So we've got our filtered jobs. This example is just filtering from this taxi ride source. We're filtering all of the rides that do not end in New York City. And then we get the result of that and can do additional processing on that. Next and finally, we just execute the job. And from that point, this would be, at the end of your main class, and you can then go and package up the jar file using Maven, and then deploy it into Flink and get going right away. And that's it. I can show you quickly what the source code looked like for the streaming job, which I demoed. It's very, very simple. It's this Kafka streaming here. So basically, oh, you know what? I think I have a slide on this. Sorry. Okay, let's come back to that. So here's the Kafka consumer that I used for the demo. So this was this is a consumer which is included with Flink. You just give it some properties for the connection parameters, and that's all there is to it. You also need to give it the schema of the messages that you expect so it can serialize things properly, but that's, kind of a given and not too difficult in most cases. Tell it the topic, and this consumer is then passed to the add source method here, and the return value is your stream, and you can start processing those Kafka events. So quite simple. So now we can come back to this example here. What I meant to show here is this is what the managed state in Kafka looks like. So as I was talking about earlier with the fault tolerance and having Flink manage everything for you, the way you can do that is when you set up the streaming job, when you're writing the code for your streaming job, you are given access to this runtime context. You can then get a state variable, for example, this value state, and the way you do that is by passing a value state descriptor and specifying what the data type should look like. So here I specified it should be an integer class with the name of sum, and then the result is we get this value state, which is just a container for the actual value that you're going to be using. So then on this sum value state, I can set any integers that I want, and then this is registered with Flink, and if the node goes down, there will be snapshots of the state, and you can get things quickly back up and running if things go badly. And that's all just managed for you. You don't have to worry about it. So, and there are good examples on the Flink website of how to use managed state. I won't show you any of that, but it's really quite simple. It's really just as simple as this. You get the managed state, and then you just use this in your streaming job, and it takes care of everything for you. So, next, how does Flink compare to other streaming platforms? So, as far as Spark goes, Spark was and is primarily a batch processing engine or a batch processing platform. Now they have implemented streams, but they're implemented using batches or what they call micro batches. So they're just very, very small batches that are so small and come so quickly that they kind of look like streams. That's why there's this something like minimum group interval or something like this configuration option in Spark, which is basically just the minimum interval time for a micro batch. And I think they recommend that the minimum time is 50 milliseconds. So what that means is that for all the events that you're getting in Spark, there is this inherent latency that will exist on all events that you receive. Because Spark was originally written as a batch processing engine. Now, the difference with Flink is that it was originally written as a stream processing engine or platform. So everything is written as streams. So all the events that you get them real time. Now, they do also support batch processing, but the batch processing is implemented using streams. So it's kind of the opposite of Spark, where Spark uses batch processing to implement streams. Flink uses stream processing to implement batches. So that's the basic difference between Spark and Flink. Now with Kafka streams, everything's quite similar. Deployment obviously is very different. The Kafka Streams API is just a Java library that natively connects to Kafka and starts sending you messages, starts sending you events from Kafka topics. And that's nice, and you can get up and running quite quickly with Kafka Streams. It's very lightweight. It's good for microservices and, just to get something up and running trivially. I don't know. In my opinion, getting going with Flink was trivial as well. But it is definitely the case that Kafka Streams API is more lightweight, because with Flink you have to have this separate dedicated cluster, which is a standalone Flink cluster. So what that means is that deployment with Flink will look very different than what it looks like with Kafka Streams API. So where with Kafka Streams API you just have your application, which is deployed somewhere and is up and running, and then connects to a Flink cluster, which is running somewhere. Whereas with, sorry, I think I said Flink when I meant Kafka. So you have your application up and running somewhere, which is connecting to your Kafka cluster running somewhere. Now with Flink, you would have a dedicated Flink cluster where you deploy your job, your streaming job, into that cluster, and then independently of that, you have a Kafka cluster running somewhere. So then, you know, you have further implications of that, such as whoever is managing the cluster will typically be different. So whoever's managing your Flink cluster will typically be different from whoever's managing your application and wherever that's running. So there are some subtle implications there. But these are the fundamental differences between the two. I won't talk about Apache Storm, but I think Spark is what comes up most frequently. Okay, and finally, just to give some credibility to Flink, because I think a lot of people have not heard of it unless they're you know, working in the stream development field quite often, or you know, have been, you know, working with streams for a long time. Flink may not be something that they've heard of. In fact, it is used quite a lot in production. Some really incredible systems deployed and up and running using Flink. And of course, this is always very important when deciding whether or not to go with a project and whether or not it's safe to invest time and effort and money into using something that is open source and maybe not as well known as something like Spark or the Kafka Streams API. So Uber has an open source streaming analytics platform called AthenaX. This was built using the SQL API exposed by Flink. So this thing is processing several million messages per second and is running in production. Alibaba is the largest e-commerce retailer in the world. They have hundreds of Flink jobs on thousands of nodes with terabytes of state. They're also using the SQL streaming API for machine learning on their search infrastructure for their e-commerce site. They, at least at the time that I was researching this and recorded this presentation, they are using a fork of Flink called Blink. But they are in the process of migrating that to vanilla Flink installs. I think they've contributed most of the changes that they've made back into the core Flink project, and so they're trying to migrate everything back to just vanilla Flink. So that's encouraging as well, because then you know that you've got quite a lot of progress being made on the core Flink code base. Next, ING built their risk assessment engine based on Flink. Because it is the risk assessment engine, they need to be able to quickly swap out different machine learning models at runtime with no downtime. You know, say they identify some new risk and they've built a new machine learning model, and they need to swap that model in with something and keep things going in the meantime. They're doing that using Flink. Finally, Netflix has over 3,700 different Docker containers running Flink on 1,400 nodes with over 22,000 CPU cores and over 4,000 Kafka brokers on 50 plus clusters with hundreds of data stream Flink jobs running. So obviously they've got massive usage of Flink and Kafka running together. So you can be sure that in production, obviously this is where Netflix is using Flink. In production, it is a reliable platform and would be safe for you to use on your project. So that's all I have. I hope this was helpful. Yeah, good luck with Flink or whatever streaming platform you decide to go with.